question here, we're being asked to determine the size of the resultant force that is acting on this boat. There are two forces that are directly acting on the boat. One of the forces is due to the oars, the person pulling it on the oars, rowing the boat across, and we're told that the size of that force is 150 newtons, and the other force is due to water flowing down the river, that's in that direction there, and we're told that the size of that force there is 200 newtons. So in order to work out the resultant, we need to represent these two forces on this graph here. And we're going to use the scale. One of those little squares, those are 1 millimeter squares, one of those little squares there I've decided will represent a force of 10 newtons. So in order to represent a 200 newton force, I'm going to need to draw a 20 millimeter line. So let's draw that in there. We'll put an arrow there to show that it's a force, and that's representing a force of 200 newtons. And then the other force is this is going to be a straight line with a magnitude of 150 newtons. So we'll put that in from there, and that's going to go along in that direction there. It's going to go 15 of those little squares along, so it's a 15 millimeter long line, and that's representing our force there of 150 newtons. So we'll just put that in there. Now, as you'll see, what we now have are two sides of a rectangle, and that's a really important idea, because what we now need to do is to complete this rectangle, because that will enable us then to work out the size and also the direction. It'll show the direction of the resultant force. So there's the third side of the rectangle there, and then the fourth side of the rectangle. Let's make sure that we've got that absolutely lined up there as close as I can. So we've got the four sides of the rectangle from this, and what we're now going to do is to draw in the diagonal, and the diagonal is going to start at the starting point of those two forces there. So that's our starting point there, and there's our diagonal going in across there, and this is a force, this is a resultant force, and of course, this line here is 15 millimeters long. This line here is 20 millimeters long. And if you were then to take a ruler and to measure the length of that side there, this is a scale drawing, that would be 25 millimeters long. And of course, we're using a scale of 1 millimeter square. It is 10 newtons. So in this case, that would have a size there. The magnitude of that force there is 250 newtons, because if you measure it, it's 25 millimeters long. It's also important to work out from this, or to look at this and say, is that a realistic answer? Well, that side of the rectangle is 200 newtons long. This side is 150 newtons long. So is it plausible that that's 250? Yes, it is, because the diagonal is obviously going to be rather greater, but not hugely greater than that size there. So 250 newtons is a very plausible response. So that's the size of the resultant force.